Hi everyone, I'm Mungirwa Tanasias Maingi from Faculty of Engineering and Technology. I'm from Department of Electrical and Electronics Engineering. I'm presenting an innovation by the title Pico Hydro Power Production. Pico Hydro is a term used to describe power under 5 kilowatts. And with this innovation, you can produce power anywhere in the country, even in northeastern where there is a minimum water. So you can produce power anywhere. My project is, my innovation is addressing a very critical issue in the country. It is touching on the Big Four agenda, the manufacturing part, and the Vision 2030. To be an industrialized nation, you need power, and you cannot manufacture without power too. And this idea tricked my mind when I realized very big projects, even the state projects, could not run smoothly because there is no power in some remote areas. For example, the laptop initiative for the kids. It needed to pick up because some places, some primary schools were so remote and there was no power and green, the green supply was not in that place. So with this innovation, you can produce power to those places where there is no grid reaching there for their own use. So you can produce this power for an institution like school, for an hospital, for an industry, for a small town, maybe starting even in very remote areas, and that brings about growth and the technology that we need today. To understand this innovation, you really need to understand what happens in the hydros, in the hydroelectric power production power stations. First of all, what is currently happening in the hydros is that they build where there are power a river flowing, or there is a water flow somewhere, maybe a river, and they build a reservoir to tap that water, and they use that kinetic energy from the water to run the turbines, and the turbines rotates the generator. The generator produces electricity, and the electricity then is fed to the appliances, to the consumer loads. And the main issue for power engineers, they will tell me, or they will know that the main challenge that comes about in power production is to maintain frequency to 50 hertz according to the Kenyan energy regulations. All the energy or the power, the electricity that you use must be running at 50 hertz. So how they do it today is that they limit the amount of water hitting the turbines such that the required only amount of power to be used is the one being produced. But in my case, so they limit the rotation of the generator to the power that is they want to use. But in my case, I don't limit the production of power. I let all the power to be produced, the generator to run at its maximum. Then I control frequency by use of dummy loads on the consumer part, by use of dummy loads. And dummy load is like a sacrificial load, whereby if we have two equipments that needs to run, let's say a generator and a pump. So my pump has to go, if the power is not enough, a pump has to go off automatically so that the generator can run. After the generator is done with its process, then my dummy load can come on again automatically and continue the process. So a dummy load will go on, off or on to allow the main component or the consumer component to be running. So I use the dummy loads. So after the generation, I feed the consumer loads and the dummy loads with the electricity that have been produced. So let's say if I am powering 100 homes, it means when all the 100 homes, the equipments in the 100 homes or the 100 equipments are on, the generator should be running at 50 hertz, at the speed of 50 hertz. I mean the frequency of 50 hertz. And if all the equipments are off, all my dummy loads should be, if all my dummy loads are on, the generator should be running at 50 hertz. So they will be sacrificing each other. If the consumer starts putting off their loans, then my dummy loan starts coming on automatically to maintain the frequency of the generator at 50 Hertz. So, you know, according to standard, speed of the generator is given there by 120 F over P, where P is a number of poles of the generator and which is constant. And 120 is also a constant, it's a value and it's a constant. That means the speed of the generator is directly proportional to the frequency. So if you can control the speed of the generator, you have controlled the frequency of production. So, and again through standard, is the more you load the generator, the slower it will tend the slower it will tend to run. If you release the components, the faster the generator will tend to run. So the same criteria I'm using here. When the customers are loading the equipment, they are putting the equipment on, the generator will start slowing, and then my dummy loans will start going off automatically. And if the dummy loans, if they started again switching off, the generator, it means it is being released, it will go faster, and my dummy loans will start coming on automatically. Now, this, here comes the most encouraging bit of my innovation. How am I using these dummy loans? I'm not wasting power by letting these dummy loans to come on. After the water has hit the turbines, then initially what is happening, just the water flows along the river, with the river. But in my case, if, for example, if in places where there is no water, I create a reservoir. Then that kinetic energy hides the turbines, the power is produced. Then that flow of water, the water after it has been used, it is again collected in another dam. So when customers are not using the produced power, my dummy loans are all on. I use them as pumps to pump water back to the reservoir. So that tells you there is a continuous flow of energy production at 50 Hertz, and again the water which has been used is again being pumped back to the reservoir. So that tells you at any given time, power is being produced at 50 Hertz, and again it's being pumped back to the reservoir. That means that will be a continuous process. Every time power is produced at 50 Hertz, every time water is being pumped back. So even in places where there is no water, you can create a reservoir and a dam, and the process will just repeat itself. And that's how this project, this innovation is very practical, and according to me, it is inevitable. If actually the implementation of the project is inevitable, if actually we are serious with the Big Four agenda, the Vision 2030, and providing citizens with high quality life with clean environment and security. So maybe if I can demonstrate how the innovation works, how the dummy loans will be releasing themselves, and how customers will be coming on and off automatically. You can see in this innovation, the prototype that I've built is that when the speed, this RPM is revolutions per minute. When the speed of the generator is below 50, there will be no dummy loans. That means all the customers are using the equipment. Power is being used to the maximum. That means my dummy loans should be off because the generator is already running at 50 Hertz. And when the speed of generator starts rising, maybe from 50 to 100, that means some customers have switched off their machines and my generator is running very fast. So that means my dummy loans, one dummy loan should come on to compensate for that equipment that have went off, so that the frequency can be maintained at 50. Above 120 to 210, another dummy loan should come on. Above 210, all the dummy loans should be on. That means all the customers have switched off the equipment, maybe they are asleep, and all my dummy loans should be on. My dummy loans now, at that time, they are busy pumping water back to the reservoir. So, and that's how it will be. When the customer starts switching on, the equipment then they will start going down, switching off again automatically. So what I'm doing here is a representative of customers now putting on the equipment, and no, that's an electrical noise. You see now the frequency it's at 168, it's above 120 but below 210, and 2 damelons are already on. If I start increasing the number of customers who are, reducing, another damelon comes on. You can see the frequency it's above 210, it's at 225, the speed, and I have my full damelons on. That means all the customers are off. If I start reducing the equipment, then the damelons should start coming off automatically. You see, it's now below 210 and 1 damelon is off. If I continue reducing the equipment, see, another damelon is off. And if I continue, all the damelons are off. And if I increase, the process repeats itself again